Hello everybody, let's get started now actually creating the library for our two-dimensional games using MonoGame. So we'll actually create the library file, and the other thing I'd like to discuss is the coordinate system we're going to use as well as sprite rendering. So we'll actually get some sprites drawing on the screen with our new coordinates. So let's start our project here. We have the MonoGame PAL tester, and I know I talked in the previous video about what we're going to name our file. I was thinking MonoGame PAL or MonoGame Helper, but I think I'm going to name this the flat library. Flat in reference to the fact that everything is going to be two-dimensional. It's going to take place on a two-dimensional plane, and I'll have a camera that can view that plane and zoom in and out. First things first, let's create our library file. So we're going to add a new project. And available to us from MonoGame, we have something, if we scroll down here, a MonoGame Net Standard library. And as you can read here, we'll be able to write code in this library that we can share between different platforms or different MonoGame projects. So click next on that. I'm going to save this here, and let's call this flat, and this will be the flat library. Now, since we're not going to be able to run a game directly from this library is just going to contain code to make programming easier. Let's go ahead and take out the game1.cs. So now that we have that created, let's get started with our coordinate system. So I'm going to draw what this is going to look like. So normally, let's go ahead and draw a screen here. So let's just say this is our screen. Normally, when we're drawing in two dimensions, the origin is here on the top left of the screen, and then x goes positive this direction, and then y goes positive on this direction. I'd like our coordinate system to look more like a normal world coordinate system where y is up and x is to the right. Okay, so we got plus x right, plus y is going up. And so if I go back here, what we're actually going to do is I'm going to change it so the bottom left is the origin, and then as we go up, we're going to get positive y. As we go right, we'll get positive x. So let's go ahead and create our sprite class. I'm going to add a new folder, and it's going to be inside the graphics namespace for our library. Inside the graphics folder, we're going to create a class, and let's call this sprites. And all I'm going to do with this is basically wrap the sprite batch class that comes with MonoGame. So let's bring in the MonoGame framework. We'll need the framework as well as graphics. So inside our class, we'll have a reference to the sprite batch class that comes with MonoGame. We'll call this sprites. And I do want to make this private. Here's our constructor. We're going to pass in the game class as the only parameter, I believe. The MonoGame sprite batch class is disposable. It implements the disposable interface, so I also want to implement disposable for us. And so in order to do that, I will also make a field called a Boolean value called isDisposed. I also want to save a reference to the game class. Now we'll just simply check for null. Let's save the reference to the game. And now let's set the disposed flag to false. And the sprites is going to be equal to a new sprite batch. And it just wants the graphics device, so that we can get from the game class. And there we go. And let's finish off with the dispose method. First we'll check if it's already disposed. We'll just return. I'm not going to have any non-managed items in this class. Normally what you would do is you would put something in here. You'd have like a private, or well, in this case private because the class is sealed, and then I'd have a variable called disposing. Then I would say if disposing, we would dispose of the disposable items. Okay. And then I would probably suppress the finalizer for this class. And I would set is disposed to true. But I'm not actually going to have a finalizer here at all. I'm not going to have any non-managed items at all either, so I don't feel the need to really implement that part of it. If we call dispose, it's just going to check if it's disposed, and then call the dispose method for any of the managed objects in here. This needs to be public, and there we go. Okay, so that'll take care of the disposable. The sprite batch is created, and we've just basically wrapped what MonoGame does for a sprite batch. And to continue that wrapping, we'll just make a begin for our sprite batch. And we'll just call the sprite batch begin method. We'll end here, and that'll just wrap this method. And then we'll have a draw call. We'll need to pass in a texture. Scroll down here, there we go. And we'll make this fairly simple. Let's just have a texture, let's have a position, and a color. And maybe we want an origin as well. Let's provide an origin for the transformation. Okay, so that looks good. From there, if you look at it now, it kind of doesn't really make any sense for me to wrap the sprite batch class, because I'm just basically calling the sprite batch functions directly from my own functions, so there really isn't any need for that. Here's where I want to change the coordinate system. So we can do that now by creating an effect. So let's create a basic effect, and I'm just going to call this effect. Here inside the constructor, let's create the effect. That also takes the graphics device. Effect is kind of a general purpose basic vertex and pixel shader, and so I want to get rid of some of the parameters that we're not going to use. One of them is fog enabled. I'm going to set that to false. We don't need any fog for our 2D game. Texture enabled, I want to set to true. Lighting, we do not need any lighting, so we'll set that to false. The effect.vertex color enabled, we do want to change the vertex colors sometimes. In fact, when I pass in the color parameter here, that'll set the vertex color, which will then change the way the sprite looks, or change the color of the sprite. And then we have let's set up the matrix classes. So the world, in this case, it's always going to be, let me think about that. In this case, I think we're always going to be just the identity here. We're never going to change it to anything else. So the world, let's just change that to identity. And that might be the default for this, but let's just put in identity. So that'll be matrix identity. Now the projection, we're going to set to the matrix identity, but that one's going to change. And then the view will also set to matrix identity. But that one, these last two will change depending on what our camera is doing. Okay, so now let's come down here and let's set up the coordinate system. So let's make a projection matrix. I'll just call it that. And from here we're going to matrix create orthogonal off center. The first one is we want the left, which will just be 0 over here on this side. So let's go ahead and draw this. This will be 0, 0, and then over here we're going to have whatever this width is and whatever this height is. So we'll just put W and H. So I put H here and W. So back here, that left is 0. The right is now going to be that width. Well, I'm going to, let's put width in there just as a placeholder for now. The bottom is going to be 0. The top is going to be the height, whatever that is. The near plane will be 0, and the far plane will be 1. Okay, just some default values for that. So really the only values we care about here are what this width and this height are going to be. And we're going to get that width and height from whatever the viewport is. And we get the viewport by going through the graphics device. And we just call viewport like that. And we can save that to a variable called viewport like that. Then we can just supply the viewport here, the viewport width, and the viewport height. So now we have a projection matrix that specifies everything we need to change the way our coordinate system looks. We need to tell the effect what this projection matrix looks like, so we'll set that to projection. And in fact, we can clean this up a little bit just by saying that the effect projection is equal to this, and then we don't have that extra variable in there. Finally, we need to provide the effect to the sprite batch, and we do that in the begin function. The sort mode is fine. The blend state, I'm not sure what they have for the blend state, so let's just take a look. So blend state, which one do we want? The alpha. Let's just set that to alpha blend for now. We may want to set different variables, maybe additive for different things, but let's set that to blend alpha for now. The sampler state will be another one. And let's set that to, for the most part, we're going to want point sampling. But occasionally we're going to want to use linear. So let's give the option. In here we're going to say, is texture filtering enabled? So the default sampler state will be this. We'll make the default point clamp. And if texture filtering enabled, then we'll change that to be linear. There we go. And so we can just provide that as the argument here. Next, let's see, depth stencil state we don't need to set. The rasterizer state, let's take a look at that one. I think I want to set that to none. Yeah, because regardless of which way the sprite is facing, I would like to be able to view that. So let's none. Then we can provide the effect that we created, and finally we don't need a matrix transform at the end there, so that'll be the last of them. And let's see, it's giving me, doesn't like the blend state there. Let's take a look at why it doesn't like that. Did I not spell that right? Blend state. Named argument blend state is out of position but is followed by an unnamed argument. Oh. Okay, so I've been calling these out of order pretty much by specifying what each one of these is. And I did that correctly until I got to the end here when I just put the effect without telling it which parameter this was. And so if I'm going to do this, I have to name each parameter. So here we need to name this parameter. And this will simply be effect. And that should take care of that. Okay, there we go. So that's all set up, ready to go. That'll use the new coordinate system. Finally, the draw call. Let's just call through the draw. We'll pass in the texture. I think we want this method from the sprites draw. So we'll just pass through the position that we're requesting. The source rectangle is going to be null. We'll just use the whole rectangle. Pass in the color. Pass in the origin. Oh, it wants the rotation before the origin. So the rotation, we're not going to have rotation with this function, so that'll just be 0. The scale will be 1. We'll keep it the same size. The sprite effects, we'll specify none for that, and the layer depth will be 0. I think we're going to have to come back and change this sprite effects, but let's take a look and see how this works. We'll just test this out right now and see if it's working. So there's one last thing. If I try to access the flat library, it can't find it yet, right? So I can't say using flat, and I can't say using flat graphics either. It doesn't know those namespaces. I need to bring in a reference to that library into the main game library that I'm creating here. So we'll go to dependencies and add a project reference. Under projects, we got the flat there. Let's check that and say yes, and then this should go away. This error should go away, I think. There we go. I want to check the properties on my library and see what the target framework is. So here we've got .NET Center 2.0. I'm going to switch that to 2.1. Right now I'm going to use the most recent version. Yeah, let's do that. We'll keep it like that. And so now everything should compile. We're using those namespaces just fine. And if I run this, we're just going to get the same window we had before, but now we have access. So we're not going to really see any changes, but now we have access to the sprite drawing routines that we created. Let's start drawing some sprites. I need to create the object, so let's make sprites. We're going to initialize that here, so let's say sprites equals new sprites. It wants the game class as a parameter. Let's go ahead and run that and make sure everything runs smoothly. That looks good. It's compiling and running just fine. Now we tell the sprites that we want to begin drawing. Texture filtering enable, we'll set that to false. We don't need texture filtering right now. And then we'll end the batch. And so the way sprite drawing works is in batches. So you tell it the beginning of the batch, then you draw every sprite you want to include in that batch, and then you tell it to end. And when you end, it's going to take that whole batch and submit the whole thing to the graphics card all at once, and it's way more efficient than just sending one sprite to the graphics card, then another sprite to the graphics card. We need to now use the draw command. And the first thing it's asking us for is a texture. We don't have a texture yet, so let's create one. This will be a texture 2D, and I'm just going to call this texture. And then we come here to load content. The texture is going to be this content.load, and then we're going to load a type of texture, and then we got to give it the asset name right here. Okay, so this is how content loading works in MonoGame. You have the type that we created here. It's a texture 2D. I come down here, I set that texture 2D equal to the whatever the content load command gives me back. So I'm telling the load command I want to load a texture 2D, and then here is the name of the asset that I want to load. I have not created a texture asset yet, so it won't be able to load anything. Let's go over here to the content, and we're going to click open with. Make sure you've selected the pipeline tool and select OK. And then we have the content builder. What this does is we can add all kinds of content to this file, whether it's a texture, an audio, font, or a font file. And then what it does is it compiles it all into one file that the game will use for all of its content. Now technically we could have more than one file. We could have content for different levels, we have content for different screens that are on display. But right now we're simple enough, we're just going to put everything in the same content file. And the way we add things to the content file is here we have various buttons that will give us different options. We can create folders in here, we can add files that are existing, we can create something new. Let's go ahead and add an existing item because I've already created an item that we can add in here. And if I go here, I created an image, a PNG image, just called box, and it's just a face and that in the shape of a box. So we'll click that and open. I think what I'm going to do is just add a link to the file, and it'll just look to that location every time. Now once we have it in here, we need to actually compile this, alright, because it's going to take every file or every asset that we've put in here. We want to compile it into the file, the content file, which is right here. Okay, and we just come over here and we've got build and rebuild. Let's just hit build. One build succeeded, 0 failed. So now that we have that, we can close that. Oh, and actually let's look at one more thing. Let's go back there because we need to know the naming convention. The assets can be now retrieved by using this name without the extension. Okay, so this asset name, as far as MonoGame is concerned, is just box. If we want to load that now, we would say box, and that should load the box PNG and put it into this texture. And if I run this, let's just make sure we don't get any errors, which we are now. So let's find out why. Oh, it's because I have this draw command and it's not actually doing what it needs to do. So let's just comment that out and run it and make sure our texture loads. And it does. It looks like everything's successful there. One more thing to talk about with textures and anything loaded with the content manager is they will automatically be destroyed. When your application terminates, everything in here will be destroyed. Now it's possible that you could have a really large game, in which case you have content for different levels or different areas and they all get loaded and unloaded. And so what you'd want to do is just have different content managers for all the different areas of your game. And then as they go into scope, you'd load it, and then as they go out of scope, you would unload it. All right, so now we have a texture. Let's tell it we want to use that texture. We'll just set the origin to 0, which means bottom left of the texture or the image. The position, so this is going to be the position on screen. I don't know exactly what our screen resolution is right now. We can find out by querying the viewport. In fact, let's do that. We'll say, let's ask the graphics device how big the viewport is. We got the viewport. And let's see, where do we want to put everything? So this will be a new vector. Let's just put it at the viewport width divided by 2. And the viewport height divided by 2. So that should be right in the middle of the screen. And the color will just be white. Now if you specify white as the color, that's just going to keep whatever colors are originally in the texture. So now if I do this, it should draw that face right in the middle of the screen. There we go. Okay, so it's right in the middle of the screen. And the middle part is right here on the bottom left. It's drawing it just fine. That looks good. The only issue is it's upside down. Right? And that's because I changed the coordinate system. I kind of flipped Y and said right down here is where I want 0, 0 to be. I want up to be positive and I want right to be positive. It ended up flipping the texture because of the way things are drawn. So in our sprite drawing class, whenever we draw, we need to tell it to flip it back over. Here's our draw function. And in the sprite effects, I told it I want none, but actually what we want to do is flip vertically, so along the Y. Then if I run it, it should show it flipped correctly, and there we go. There's our sprite drawing, and we have the correct coordinate system. We will make more advanced functions for drawing sprites, but that's just where we want to be to start.